So welcome back to LM386. This is part 2. And what we're going to do is start setting this this LM386 amplifier up and putting it on the breadboard. So let me remind you where we were. We had a diagram I showed you that looked like this. This diagram, I'm showing it rotated now because I want you to see that, again, there's a notch over here on this left side, and that tells you that pin 1 is over here in the lower left corner. It counts through to pin 4, and then it jumps up here to pin 5 up in the upper right corner, and then back to pin 8. So that counterclockwise counting that we were seeing. And so we're going to need to be able to identify each one of those pins. And so when I put this in the board, it's going to look just like this. So I know you can't see the label on it, but I want you to be able to correlate how I've got this sitting in the breadboard. It fits right across that trough. You can see there's a notch here. There's a little divot here. That corresponds to this on the diagram. So that would make this pin 1 on this lower left corner, pin 4, and then of course 5 through 8 would go across the top from right to left. And so that's how this is going to look in the breadboard. And again, this is pretty standard for an integrated circuit. I haven't seen any that aren't like this, and so this is a good thing to learn early on. So let's go ahead and start making some of the connections. I'll remind you about this circuit diagram that we had. On this circuit diagram, we were going to connect pins 2 and 4 to ground. We're going to connect pin 6 to the positive voltage, the battery. Pin 3 will be the input, and then 5 will go out. So let me show you these sort of one at a time. So first of all, I have some pre-cut wires that I can use on my actual breadboard. So pin 2 is going to go to ground, so I'm just going to make that connection here on the breadboard. So I'm going to use that lower rail as my ground, so hopefully you can see how that's connected up. I'm going to do another connection now with pin 4 to ground, so I'll make that right next to that one. So that'll look just like this. Hopefully you can see that's connected up correctly. The other thing that I'm going to do is I will connect up pin 6 to the positive rail, which I'm going to put up on the top of the board. So I'm going to go ahead and do that like this. So that's pin 6. So I've got all my power connections right now made, and then we're ready to now go ahead and get the input. So the input is going to come in through an aux cable. An aux cable, if you've looked at one carefully, basically has 3 connectors to it. So let me show you that. This is the aux cord. The aux cord has 3 conductors, bare conductors, 1, 2, 3, and you notice there's some black glass or enamel there. You may remember the light bulbs that we used way back, and they had the black separation, that black glass in between the threads and the bottom of the bulb. And so this is the same material that keeps these from being shorted together. So we have 3 connectors. One of these connectors will be a ground, one's going to be a right signal or right channel, and then one will be the left channel. So that's why there's 3 on these stereo aux cables. That aux cable will connect into this device. This is an aux jack, and if you look at it, the aux jack has got a ground right here. There's a pin sticking up there, and then it's got over here on this far side will be one, probably the right, and then on the other far side, the left. The 2 in between here don't do anything, they just kind of hold it into the board. So when I connect my aux cable into this like that, I've got ground coming onto this, so I'm going to have to ground that, and then I've got my signal coming out on these 2 sides, the far sides. And so when I plug that into the board, it'll look like this. And let me show you how that looks then from above. So what I've done is plug that into the board. Again, you can see those connectors from the bottom, from the side, and you can see there's 5 of them. The one in the center has to be connected to the ground rail. The connector over here closer over here, this is going to have to jump into pin 3. So that's key to it. This channel over here on the far left it would go to another amplifier, but we're not going to do that right now. The sort of in between are not going to be used here. Those are really just to hold the thing into the board. So Let me make a couple of those connections. The first one will be that ground in the center, and I'll show you how that looks. Okay, so I've got a pre-cut little ground wire, and you can see hopefully that that's running right into that center, and it's coming down to my rail on the board, and so I've got a good ground on my aux jack. The next thing I need to do is run that signal from the right hand side through a capacitor, and that capacitor is somewhere on my desk right now, and let me find it. I just had it, and I've got so many things here that I have misplaced that. And I just took it apart. And I cannot find it. Oh, but here it is. It's on the floor. It got knocked off onto the floor. Okay, so let me show you this connector. This is a little capacitor. I think it's 0.1 microfarads. It doesn't matter exactly the value, but it needs to be a relatively small capacitor. And that's going to jump from that aux cable. It's going to bring the signal into pin 3. So I'm going to set that in the board like this. So hopefully you can see that now. That capacitor is connecting from that row right there, which is where that aux jack comes in. Hopefully you can see that, and it's coming right into the pin 3. So that's the signal that's going to be coming in. That's where that would would come in. I would normally want to trim that capacitor down so the leads aren't as long. That helps out with making the signal cleaner. But right now I'm gonna leave it like that because I think it's easy for you to see on the video. So hopefully that's clear, and that's right there. Okay. So the next thing we're going to want to do is to run the output through another capacitor on the output, and so I will do that now. I've got an audio speaker here as well. And so we're about ready to do that. So I'm going to take my audio speaker, and the audio speaker I'm using is one of the stock ones from the lab. And you'll see I've got 2 wires on here. Now some of you guys aren't going to want to stop and solder these, but I would recommend soldering those leads onto that speaker, not only because it's fun, but it makes it sound better. So I've got a red and a black. That black wire has to go to ground, so I'm going to use my ground rail for that. So you'll see I've got that right down on the ground rail. And then I've also got, I'm going to bring my speaker in like this, and that speaker needs to get a connection through that capacitor, through the other capacitor that I've probably dropped on the floor, in fact. And you'll notice that this is a capacitor that's a pretty big electrolytic capacitor. If you remember from the RC circuit lab, this capacitor has the stripe on the side. And so we're going to have to be careful. That stripe side is the low voltage side, and that has to be toward the speaker. So I'm going to put that coming out of pin 5 and jumping all the way over to where the speaker is. So that should look like that. If I look at it from sort of underneath, hopefully you can see that capacitor is connected in pin 5 here. It's in line with pin 5 right there. The stripe is over here on the speaker side, and it's in line with that speaker connection right there. So hopefully you can, let me show you another look at it from the other side. So hopefully you can see that that's in pin 5 on the left, and then it comes out to the speaker over here on the stripe side on the right side. So we should be good to go with that. The final thing that we need to do is we got to put some power on this thing. And so what I'm going to do is I'm going to use a battery to do this. And so let me get my battery, and I'm going to show you a quick lesson while we're doing this. One of the things I've seen from doing this for a number of years is students will get a very nice amplifier, and it won't work. And the reason it won't work is because of this, sometimes. So let me show you something to be careful of. I've got my trusty multimeter here. I've got it set on voltage. And what I'm going to do is I'm going to measure this battery voltage real quickly and take a look at that. So I'm going to test this battery first. And you notice that that battery is sitting at about 3.7 volts. And 3.7 volts for a 9-volt battery, that means that battery is pretty much dead. So this is going to need to be tossed or recycled. It's not going to work well with this amplifier. So we're going to get rid of that, and we're going to bring in a fresh one. And this one I just got out of the box, and so hopefully this is going to be up exceeding 9 volts. And in fact, when I measure it, you notice it's at about 9.4 volts. And so this is a nice fresh battery. If these get below about 8 volts, I'm not going to try to use them anymore because the amplifier just won't work as good. So be careful about bad batteries. What I'm going to do is put a battery snap on here. You guys use these, a lot of you, during the flashlight labs, and you'll notice, you'll recall that there's a red lead and a black lead coming out. The black is going to be grounded, and that red lead is going to be the +9, which needs to go, you may remember, to that plus rail, which ends up at pin 6 on this chip. So let's go ahead and make that connection. And what I'm going to do is use a little connector known as a terminal block. And so let's come back and we'll finish putting power on this thing in the next part.